Alright, so welcome to today's class. Today we'll be dealing on chain rule. Chain rule is used to differentiate a composite function. Now this is the formula for chain rule. dy all over dx equals dy all over du multiplied by du all over dx. Let's take an example. Given that y equals x squared minus 5x plus 7 all raised to power 4, and we are asked to find dy all over dx. How do we go about this? Our first task is to identify our u. So let u be equal to x squared minus 5x plus 7. So if we differentiate u with respect to x, we would have, according to the general method of differentiation, you multiply x by the power and then subtract 1 from the power. So here we have 2x raised to power 2 minus 1 minus 1 multiplied by 5. Then you attach x raised to power 1 minus 1. If you differentiate 7, it would give you 0 because 7 is a constant. So if you differentiate a constant, it would give you 0. So dy all over dx equals 2x minus 5. So since u equals 2x minus 5x plus 7, therefore y equals u raised to power 4. Now let's differentiate y with respect to u. So dy all over du equals, you multiply u with the power, so we have 4u, and then you subtract 1 from the power. 4 minus 1 is 3. So our next task is to substitute into chain rule formula. We have dy all over dx equals dy all over du multiplied by du all over dx. So if we substitute, we would have dy all over dx equals 4u raised to power 3 multiplied by 2x minus 5. So our next task is to substitute the value of u. So dy all over dx becomes 4 open bracket x squared minus 5x plus 7 all raised to power 3 multiplied by 2x minus 5 close bracket. So our final answer is 4 open bracket x squared minus 5x plus 7 multiplied by 2x minus 5 close bracket. So this is our final answer. Let's take another example. Given that y equals 2 minus x raised to power 4 all raised to power negative 3, and we are asked to find dy all over dx, how do we go about it? First of all, let's identify our u. So let u be equal to what we have inside the bracket. So we have 2 minus x raised to the power 4. So if you differentiate u with respect to x, it will give you, if you differentiate 2 is a constant. Therefore, if you differentiate 2, it would give you 0. Minus, if you differentiate x raised to the power 4, it would give you 4x raised to the power 3. Remember, you multiply x by the power and then subtract 1 from the power. That's why we have 4x raised to the power 3. So therefore, du all over dx equals negative 4x raised to the power 3, because 0 minus 4x raised to the power 3 is negative 4x raised to the power 3. So since u is equal to 2 minus x raised to the power 4, therefore y becomes u raised to the power negative 3. So if you differentiate y with respect to u, you would have, you multiply u by the power. The power here is negative 3. So we have negative 3 multiplied by u raised to the power. You subtract 1 from the power. So we have negative 3 minus 1, which gives us negative 3u all raised to the power negative 4. So dy all over du equals negative 3u raised to the power negative 4, which can be written as negative 3 all over u raised to the power 4. This is from the concept of indices. If you've not watched my video on indices, kindly check the description box below and you will see the link to the video. So our next task is to substitute into chain rule formula. And chain rule formula is this: dy all over dx equals dy all over du multiplied by du all over dx. So if we substitute, we would have negative 3 all over u raised to the power 4 multiplied by negative 4x raised to the power 3. So if we simplify further, we would have negative 3 multiplied by negative 4x raised to the power 3 gives us positive 12x raised to the power 3 all over u raised to the power 4. So our next task is to substitute the value of u. Since u is 2 minus x raised to the power 4. So if we substitute the value of u, we would have 12x raised to the power 3 all over 2 minus x raised to the power 4 all raised to the power 4. So this is our final answer. So let's take the third example. Given that y is square root of 1 plus x raised to the power negative 1, and we are asked to differentiate y with respect to x using chain rule, how do you go about it? First of all, let's identify our u. So let u be equal to 1 plus x raised to the power negative 1. So if you differentiate u with respect to x, we would have, if you differentiate 1, it would give you 0 because 1 is a constant. And then plus, if you differentiate x raised to power -1, it would give you -1 multiplied by x raised to power -1 minus 1, close bracket. Remember, you multiply x by the power and then subtract 1 from the power. So du all over dx becomes -1x raised to power -2. So du all over dx equals -1x raised to power -2, which can also be written as -1 all over x raised to power 2. This is from the concept of indices. So since u is equal to 1 plus x raised to power -1, therefore y equals square root of u, which can also be written as u raised to power 1 all over 2. So therefore, dy all over dx, if you differentiate y with respect to x, it will give you 1 all over 2 multiplied by u raised to power 1 all over 2 minus 1. So dy all over du equals 1 all over 2 multiplied by u raised to power -1 all over 2, because 1 all over 2 minus 1 is -1 all over 2. So this can also be written as 1 all over 2u raised to power 1 all over 2. This is from the concept of indices. I will leave the link to the video in the description box below. So our next task is to substitute into chain rule formula. Dy all over dx equals dy all over du multiplied by du all over dx. So this is chain rule formula. So if we substitute into chain rule formula, we would have 1 all over 2u raised to power 1 all over 2 multiplied by -1 all over x squared. 1 multiplied by -1 is -1 all over 2u raised to power 1 all over 2 multiplied by x squared gives us 2x squared u raised to power 1 all over 2. So our next task is to substitute the value of u. Since u is equal to 1 plus x raised to power -1. So if we substitute the value of u, we would have -1 all over 2x squared multiplied by 1 plus x raised to power -1, close bracket, all raised to power 1 all over 2. This can also be written as -1 all over 2x squared multiplied by square root of 1 plus x raised to power -1. So this is our final answer.